Module 2, Database Design and Management. 1. Data Types. PostgreSQL supports a wide range of data types, including numeric, character, binary, Boolean, date, time, and more. Some common data types in PostgreSQL include numeric types, integer, big int, decimal, numeric, real, double precision, etc. Character types, char, varchar, text, etc. Binary data types, bytea, binary, etc. Boolean type, Boolean. Date and time types, date, time, timestamp, interval, etc. Enumerated types, enum. Composite types, composite. Arrays, array. JSON types, JSON, JSON. UUID type, UUID. Network address types, init, SID, etc. You can specify the data type of a column when creating a table using the appropriate SQL syntax. For example, to create a column named age with a data type of integer, you can use the following SQL command. SQL. Create table employees, ID serial primary key, name varchar, 100, age integer. 2. Constraints. Constraints are used to enforce rules and restrictions on the data that can be stored in tables. Some common constraints in PostgreSQL include primary key, foreign key, unique, not null, check, exclusion, exclude, domain, checksum. You can specify constraints on columns or on the table level when creating a table using the appropriate SQL syntax. For example, to add a primary key constraint on the ID column in the employees table, you can use the following SQL command. SQL. Create table employees, ID serial primary key, name varchar, 100, age integer. In this example, the ID column is defined as the primary key, which means it must contain a unique value for each row in the table. Note that the syntax for data types and constraints may vary slightly depending on the specific SQL variant or graphical tool you are using, so it's always a good idea to refer to the documentation or help resources of the specific tool or version of PostgreSQL you are working with. Indexes and performance tuning. Indexes and performance tuning are important aspects of PostgreSQL database management to optimize query performance and improve overall database efficiency. Here's an overview of indexes and performance tuning in PostgreSQL. 1. Indexes. Indexes are database objects that provide a fast and efficient way to look up data based on the values in one or more columns of a table. PostgreSQL supports various types of indexes, including B-tree index. This is the default index type in PostgreSQL and is suitable for most data types, including numeric, character, and date time types. Hash index. This index type is used for data types that do not have a total order, such as text or binary data. GIST, generalized search tree, index. This index type is used for complex data types, such as geometric or text data. GIN, generalized inverted index, This index type is used for complex data types, such as arrays or full-text search data. SPGIST, space partition generalized search tree, index. This index type is used for complex data types that can be partitioned into non-overlapping regions, such as geometric data. GIST, generalized search tree, index. This index type is used for complex data types, such as geometric or text data. Full-text search index. This index type is used for text search queries. Trigram index. This index type is used for text search queries based on trigram matching. Partial index. This index type is used for indexing a subset of rows in a table based on a condition. You can create indexes on one or more columns of a table using the appropriate SQL syntax. For example, to create a B-tree index on the name column of a customer's table, you can use the following SQL command. SQL. Create index customers _name IDX on customers, name. 2. Performance tuning. Performance tuning involves optimizing various aspects of the PostgreSQL database system to improve query performance and overall database efficiency. Some common performance tuning techniques in PostgreSQL include query optimization. This involves analyzing and optimizing SQL queries to ensure they are written in an efficient way and make use of indexes and other database objects effectively. Indexing. As discussed above, creating appropriate indexes on columns used in frequently executed queries can significantly improve query performance. Configuration tuning. PostgreSQL has many configuration parameters that control various aspects of database performance, such as memory usage, caching, and parallelism. Tuning these parameters based on the specific requirements of your application can greatly impact database performance. Table design. Properly designing the structure of tables, including normalization and denormalization, can also affect query performance. Efficiently organizing and partitioning data can help improve query performance. Connection pooling. Using connection pooling techniques to reuse database connections can reduce the overhead of establishing new connections for each database operation. Vacuuming and maintenance. Regularly performing vacuuming and maintenance operations, such as vacuum, analyze, and reindex, can help maintain the integrity and performance of the database. Resource utilization. Monitoring and optimizing the utilization of system resources, such as CPU, memory, and disk I/O, can also impact PostgreSQL performance. It's important to thoroughly understand the specific requirements and workload of your PostgreSQL database system and apply appropriate performance tuning techniques to achieve optimal performance. It's also recommended to regularly monitor and analyze the performance of your database system to identify and address any performance bottlenecks or issues.
Thanks for watching. For more information, like, comment, and subscribe our channel.